Hi, welcome to Advanced Math, Unit 12 on vectors. This is Part D, Page 1, Vectors and Planes. So the first page of this section is really a review of the previous one, and it starts off at the top of the page with a quick rundown on the dot product and how that works, how you do it, kind of the mechanics of it. But that's from the end of Part C. There's one thing we want to get out of that we're going to get to, which is if you have two vectors and you take the dot product of them. So here we have u and v, and we're going to compute the dot product. There are two ways to think about this dot product. One of them is this very simple operation of multiplying the corresponding components and adding those products together to get the dot product. That's easy to do. But don't forget the dot product of two vectors is also defined as the magnitudes of the two vectors multiplied together times the cosine of the angle between them. And that cosine of the angle between them is really handy because we know something about what the cosine is going to do depending upon the angle. For example, if the angle is 0 degrees, we know that the cosine is 1. And if the angle is 90 degrees, which is to say if those vectors are perpendicular to each other, we know the cosine is going to be 0. So any two vectors that you take the dot product of, if the dot product is 0, you know those two vectors are perpendicular. So without actually trying to figure out whether something is perpendicular, just by measuring the angle or something like that, you can do this dot product process of multiplying like components and adding those products together to see quickly whether two vectors are perpendicular to each other. And of course, if the angle is between 0 and 90 degrees, you'll get some factor that's between 0 and 1. And if the angle between them is between 90 and 180 degrees, you'll get a factor that's between 0 and -1. So the dot product can give you a negative value as well. Anyway, let's try this on a couple of examples. We have on example 1 a couple of vectors u and v, and we want to know, are they perpendicular? So we'll use the dot product. Not the one involving the cosine, we'll use the one where we multiply the components together. So in this case, u times v, or u dot product with v, is going to be equal to 3 times -3. Those are the x components of the two vectors multiplied together, plus 5 times 5. And so this is -9 plus 25 equals 16. So once you get to this answer that's not 0, that means you have two vectors that have lengths that are not 0. You're multiplying them together with a dot product. If the answer, the dot product, is not 0, it means the angle between those two vectors can't be 90 degrees. So this is not perpendicular, just by noticing that the dot product is not 0. Now here's another example. U dot product with v. Now we've redefined u and v as being different vectors. So we're going to take the x components multiplied together, so 3 times -5, and we're going to add to that 5 times 3. Well, that's kind of obvious how this is going to turn out. That's -15 plus 15 equals 0. And that's all we need to know to say, yes, they are perpendicular vectors. All right, next up we'll go to page 2.